previous video on intro to the unit circle, now we're going to take a look at special angles on the unit circle. So one of the angles on the unit circle is a 60-degree angle, and we're going to take a look at how a triangle has sides and what the sides are for a 60, 30, 90 triangle. Now we're going to take that triangle and put it in the unit circle. So we're going to start off with an equilateral triangle with sides equaling 1, and we're going to cut it in half. So there are my angles. As you can see, every side is 1. Now if we cut this in half, we have a right angle at the bottom, and that 60-degree angle is going to get split in half, so that's going to be 30, and the base is split in half, so that 1 is going to turn into a half. Now we're going to solve for that missing side using a squared plus b squared equals c squared. Now remember, we changed that to x squared plus y squared equals r squared. So the missing side that we have is y, and we're going to solve for that. So we have 1/2 squared plus y squared equals 1 squared. The half squared turns into 1/4, and we subtract it on both sides. So now we have y squared equals 1 minus 1/4, which is 3/4, and we're going to square root both sides. So y equals the square root of 3/4. Well, when you square root a fraction, you square root the numerator and the denominator. So the numerator is going to remain as root 3, and the denominator, square root of 4, is 2. So now we have our 3 sides of the triangle. Let's see what this looks like inside of the unit circle. Now with this being inside of the unit circle, you will see that the top part of the triangle touches the unit circle at a point. This point will have coordinates of x equals a half, because as you can see, along the x-axis we have a length of a half, and it's going to have a y coordinate of root 3/2, because if you look at the height of the triangle, that would correspond with the y-axis. So if we're looking at the height of this triangle and we go across, that corresponds with the y-axis. So the y-coordinate is going to be root 3/2, and the x-coordinate is 1/2. What you'll see is that you have the same coordinates. The only difference is the x is moving in the negative direction. So instead of positive 1/2, we have negative 1/2. Now what is this angle? Well, this is 60 degrees. So that means that the other angle is 60 degrees from 180 on the other side. So that gives me a total angle of 180 minus 60, 120. Now, if you remember correctly from the intro video, the x-coordinate gives us cosine and the y-coordinate gives us sine. So that would mean that cosine of 120 degrees would be negative 1/2, and sine of 120 degrees will be root 3/2. Now, if you take that same triangle, flip it downward, now we have the x being negative already, and now the y is also in the negative direction, but the values are still the same. So my coordinates at this point will be negative 1/2 and negative root 3/2. Now this angle is still 60 degrees, but it's 60 degrees after 180. So in total, it will be 180 plus 60 is 240 degrees. So that means that cosine of 240 degrees is equal to negative 1/2, and sine of 240 degrees is going to be equal to negative root 3 over 2, corresponding with the x and the y coordinates. Now if we flip it yet again, we will get a positive x, but the y will still be negative. So as we can see, we are 60 degrees from being a complete circle. So this is 300 degrees, because we're 60 degrees away from being 360. So the x value gives us cosine, so cosine of 300 would be a half, and sine of 300 would be negative root 3 over 2. Now we're going to get into the 30, 60, 90 proof, and it's basically the same thing. All we're doing is turning the triangle around. So if we turn the triangle around, this time we're looking for x, and we go through the same process. The hypotenuse is still 1. Now the y value is a half, because that's the vertical line. And the horizontal distance x can be found using y squared plus x squared equals r squared, where you square the half and it becomes 1/4. You subtract it on both sides, and then you square root so that you get x by itself. And the square root of the numerator is root 3, and the square root of the denominator, square root of 4, is 2. Now let's fit this into the circle. So here you can see the x coordinate will be root 3 over 2, and the y coordinate will be a half. As we move around the circle, you'll notice that we will have the same x and y coordinates. The only difference is whether they're positive or negative. So as we go into the second quadrant, we see that the x is negative and the y is positive, same numbers. And we are 30 degrees away from 180. So that means that this angle is 150 degrees. So if I want sine of 150, sine is the y coordinate. It's going to be equal to a positive 1/2. If I want cosine of 150, cosine is the x coordinate. So it's going to be equal to negative root 3 over 2. And then when we flip down, we'll be in the third quadrant where you have negative x values and negative y. So cosine of this will be negative root 3 over 2, and sine of this angle will be negative 1/2. What is the angle? Well, we are 30 degrees away from 180. So this angle is 210 degrees. As we flip over into the fourth quadrant, where x is positive and y is negative, we are 30 degrees away from being 360. So that angle is 330 degrees. So again, sine of 330 will be negative 1/2, because sine is y, and cosine of 330 degrees will be positive root 3 over 2, because cosine is x. So let's take a look at the 45, 45, 90 proof. So we're going to start off with a 45, 45, 90 triangle with a hypotenuse of 1. And then since the two angles are the same, the two sides are the same, and y will be equal to x. And we're going to solve for x using a squared plus b squared equals c squared. So let's start off with that triangle. And as you can see, when we have both 45 degree angles, these two sides are the same length. And those two sides are x and y. So we're going to start off with x squared plus y squared equals r squared. Since they're the same, I'm just going to make both of them be x. So So we have x squared plus x squared equals 1 squared. 2x squared equals 1. Divide both sides by 2. And we get x squared equals a half. Square root both sides, so we get x by itself. And I get 1 over root 2. Now, if you remember from our previous video, whenever you have a square root at the bottom, we're going to do what we call rationalizing. And that causes the root 2 to go on top. And the thing that's inside of the square root, the 2, will go at the bottom. So that becomes root 2 over 2. Again, we get this by multiplying the top and the bottom by root 2. So 1 times root 2 is root 2, and square root of 2 times square root of 2 is equal to 2. So since x is root 2 over 2, y is also going to be equal to root 2 over 2. Let's fit this inside of the unit circle. So here we have it, both the x and the y coordinates are root 2 over 2. If we flip this over, we can see that the x coordinate will now be negative, the y coordinate is still positive. If we flip it downward, you will see that both the x and the y are negative. We flip it back over to the right, and you can see that the x is now positive and the y is negative. So again, cosine for all of these angles will be root 2 over 2, and sine for all of these angles will also be root 2 over 2. You just need to make sure that it's either positive or negative, depending on which quadrant you're in. So if we're 45 degrees away from 180, that means that this angle is 135. If we're 45 degrees from 180 right here, that means that this angle is 225. And if we are 45 degrees away from 360, it means we're going all the way around, and that will be 315. So these are some common angles that are in the unit circle. The other angles that are pretty common are the quadrantal angles. So remember, the quadrantal angles are 0, 90, 180, 270, and 360. And each quadrantal angle will have an x and a y output of either -1, 0, or 1. Let's see why. Now we'll start off with 0 degrees. Remember, the unit circle is inscribed on an x and y axis where all the intercepts are at 1. So over here, my x-intercept is at 1. Up here, my y-intercept is 1. Over here, my x-intercept is -1, 0. And down here, my y-intercept is 0, -1. So that means that cosine of 0 degrees is equal to 1, and sine of 0 degrees is equal to 0. As we move up to 90 degrees, we will see that cosine of 90 is equal to 0, and sine of 90 is equal to 1. Again, this is because of the x and the y axis. So cosine is 0 because the x coordinate is 0. Sine 90 is 1 because the y coordinate is 1. As we move over to 180, you'll see that the x coordinate is -1, the y coordinate is 0. As we move to 270, you'll see that cosine of 270 is 0, sine of 270 is -1, and as we move to 360, you'll see that cosine of 360 is 1 and sine of 360 is 0.